Welcome to our Recall Prior Knowledge for Chapter 3. In this chapter, you will be required to think back to your adding and subtraction of decimal rules, where we line up decimals and we consider keeping the same place values stacked in our algorithm. You'll also move on and you'll talk about expressing improper fractions as mixed numbers. So oftentimes we end up with an improper fraction doing our math strategies or steps, but then when we're done we want to be able to give a meaningful answer in mixed number form. Another section that we'll refer to today is called mixed number to improper fraction. So if I'm getting ready to combine fractions with unlike denominators, or I should say mixed numbers with unlike denominators, it's best that I get that whole number put right into the fraction as an improper fraction. So for that reason, we're going to practice some of this in isolation today as well. The last skill you were required to review for Chapter 3 was multiplying fractions by fractions. And this ties nicely to our fraction division that you're going to see this week in core. But basically, I need you to recognize that looking at the example here, they are not finding common denominators. Instead, they're multiplying either straight across, or we may look for some cross simplifying to make our numbers a little bit smaller to work with. Let's go ahead and get started. Back to the first page where we're working with decimals, adding or subtracting. This top section is called Quick Check. So I'm going to give you a quick moment to try these with me. If you are feeling comfortable after seeing the first one or two, you're definitely welcome to move on at your own pace. Number 1, add or subtract, it says. So this is an addition problem. On my line sheet of paper, I would take the numbers I'm given, the 4 and 59 hundredths, and I would stack my decimals on top of each other. And I'd make sure that I have one digit for each digit in the first number, meaning if I need any placeholders of 0, I might include them now. These numbers were really nice because if you look, we were given both numbers to the hundredths place, and both numbers only had one digit in the ones place. After I get these numbers stacked, I can start in the smallest place value to the right, which in this case is the hundredths. If you had 9 hundredths plus 2 hundredths, you'd get 11 hundredths. Normally we'll keep just one of those hundredths there and trade 10 of them in for a tenth instead. So we'll regroup a tenth over here. Now I have 1/10 and 5/10 more. Well, 1/10 plus 5/10 gets me 6/10. And next I run into this decimal, which tells me to bring it straight down with addition or subtraction of decimals. That will be a good rule to use. It helps us separate our whole numbers from the fraction or decimal parts. Next I have 4 ones plus 1 gets me 5 ones. Final answer, someone might say 5.61, but I would really prefer you to read it with place value in mind. So I look here at that last place value so that I know it's in the hundredths place. So I would read this whole number first, 5, and when I get to the decimal I would say the word and next I would read 61 hundredths. 5 and 61 hundredths, final answer. Let's take a look at number 2. In number 2, it's a subtraction, and I need to be really careful with that one because subtractions are not commutative. They cannot be rearranged. So the first number I'm given is the 9 and 4 hundredths. It has to go on top. And next I'm going to take away 6 and 32 hundredths. The decimals have to be stacked, and the 6 goes in front of the second decimal, and the 32 hundredths goes behind it. And I'm really ready to look at subtracting the different place values. So starting here in the hundredths place, 4 hundredths take away 2 hundredths leaves me with 2. 0 take away 3. Well, that would be difficult. I might get a negative tenth or something along that line. So instead, we'd encourage you to go to the ones place. We could leave him with 8 ones, and we could break that 1 into 10 tenths. So now I have 10 here in the tenths place. 10 take away 3. Well, let's put the 10 in our head and count backwards. 9, 8, 7. I'd get 7 tenths. I'll bring down that decimal because I'm separating my whole numbers from my decimal place values. And I have 8 ones, take away 6 ones, gets me 2 ones. And if you didn't believe me, we could have put the 6 in our head and counted up. 7, 8. Oh, that was 2 more, wasn't it? Final answer, 2 and 72 hundredths. That goes to the hundredths place, doesn't it? The last one I'm going to do for you on this page is number 3. So taking number 3 here and stacking it up the way it was given to me. I could reorder it if I wanted to, but I'm just going to start with the 5 and 8/10 the way it was given. And I really want you to be careful that this decimal is aligned. So right underneath it, I need to see a decimal point. In front of that decimal, I see a 0, so a 0 under the 5. Behind the decimal, I see a 2, so 2 under the 8. And next, I see a 6 at the back. So the 6 is kind of sitting out here on its own, isn't it? I'm going to show you that I want to add those together. I'm trying to find the sum of these two decimals. You might notice that this could be a bit of a problem. A lot of students are going to shuffle that 26 over just to make sure the numbers align. You don't want to do that. The decimals align to separate our place values. So instead, we'll use a placeholder at the back in the hundredths place. We are really ready to add these up. We would say 0 hundredths plus 6 hundredths gets us 6 hundredths. And next, 8 tenths plus 2 tenths gets us 10 tenths. 10 tenths is really the same as 1 whole, isn't it? So I'll trade those 10 tenths in for 1 whole over here. 5 plus 1 gets me 6. And that decimal again should move straight into your quotient. 6 and 6 hundredths is the final answer. There are several examples down below that you'll want to try on your own next. And just looking ahead, I noticed that number 4 is quite nice. I have one whole number, I have one number in the tenths place with both of my decimals. So those are going to line up pretty nicely, aren't they? But looking ahead at number 7, do you see how we could have a problem? There's one number preceding the decimal in front of both numbers. But behind the decimal, here I have one placeholder, one place value, and in the next decimal I have 2. For that reason, I might have to use a placeholder behind this 7. I might want this to say 5 and 70 hundredths plus 4 and 63 hundredths. I also see a similar problem happening here in number 10. I have a whole number for both, and I have a decimal for both. I have a tenths place for both, but notice that this one goes to the hundredths and the other number does not. You might want to put a placeholder behind the 2 to make it 7 and 20 hundredths when you go to subtract. I'm going to ask us to take a look at the next section. So again, here we're moving from improper fractions to mixed numbers, improper to mixed. If you look at the example at the top, they really recognize their multiples of 6. So they were counting 6, 12, 18, and they knew 18 plus 2 more would get them to 20. So when they were dealing with that 26, they were kind of thinking of multiples. We will do something similar, but we oftentimes will use long division to get there. Here we are on the next page. It says, express each improper fraction as a mixed number in simplest form. So for number 1, I'm given this improper fraction, and I could count my multiples of 4 if I know them. 4, 8, 12, 16, 20, 24, 28, and that's about where I'd stop. That would absolutely work. That's a strategy they show you up top. There's another way of doing this. So number 1 on my line paper, I could always recognize that fraction bars secretly tell me to divide. I always divide the top by the bottom. So I'm going to have 30 divided by 4. And I'm going to think of my multiples of 4. I'm going to see how many times 4 will go into 30. So similar to the strategy at the top, but I'm showing you a long division to get there. So I could say, again, 4, 8, 12, 16, 20, 24, 28. That's about as close as I'm going to get, isn't it? So 28 will go in my subtraction at the bottom. But how many groups of 4 was that? A bundle of 5 plus 2 more makes 7. That 7 probably doesn't want to sit in this first place value, because if it does, it would mean 4 goes into that 3/10 7 times nicely. And I'm not sure that's true. I think it's saying that 4 goes into 30 7 times. So I'm really using that entire value all the way to the 0. 30 is what I split into 4 groups of 7. When I'm done, I multiplied 7 times 4 to get that 28. Again, thinking of those multiples. And if we count up from 28, we could say 29, 30. Oh, that was just 2 away. Don't have to do regrouping for that if I see it another way. And I could write this as a final answer. I could take this and write 7, using that whole number at the top in my quotient, and the remaining pieces as my numerator, and the divisor stays the same as my denominator, 7 2/4. Not too shabby. In fact, you get yourself a smiley face. But is there a better way to get this answer into a final form? The answer is yes. Could I also simplify this fraction? Does something go nicely into 2 and 4? Maybe you notice that they're both even, in which case we could divide them both by 2. And if I do that, that whole number will not change, but I'll have 2 divided by 2 is 1, and 4 divided by 2 is 2. I get a final answer of 7 1/2, and you get yourself maybe a gold star, or purple if you're lucky. For this next problem, we're given 17 halves. If you notice, that's an improper fraction. Sometimes we joke about the elephant smushing the chicken. So the top number is too big for the bottom number. In this situation, it'd be really nice if I was on a pen, wouldn't it? I'm going to try to show you that this fraction bar reminds us to divide. So again, at the top, the strategy that they're showing you is counting multiples of 2 to get there. Well, we kind of cut down on the multiples idea, and we let you do a long division. So let's take the top number and we'll divide by the bottom number. It's always top divided by bottom. You'll also use this in 7th grade when you start turning fractions into decimals. So taking a look, or maybe counting by 2s, we would say, let's count by 2s and get as close to 17 as we can without going over. So we'd count 2, 4, 6, 8, 10, 12, 14, 16. Oops, 18 would be too much. I better stop there. Again, remember, I just counted to 16, so in a moment I'll have to use that in my subtraction. Well, how many groups of 2 did we say that was? That's a bundle of 5 plus 3 more. That will make 8. 5, 6, 7, 8. We'll put an 8 up here in my quotient. Remember, I'm not putting it in the tens place because I didn't have enough tens to break into 2 nice groups, did I? And 8 times 2, when I was counting, got me 16. When I subtract, I'm left with 1. Let's go around the ring of fire. Let's write this in a final answer format that looks more like a mixed number, so it has a whole number that comes from the top, 8, and it has our leftovers written as a numerator, and the denominator comes from our divisor. It stays the same actually from the original, if you notice, unless you can simplify as a final step. There's one more I'm going to look at with you, number 3, which shows we're going to divide again. I'm going to divide the numerator by the denominator, and I'm doing that because the numerator is too big. It's smushing my denominator. Elephant smushing chicken, terrible, right? But when I'm done, a chicken going for a ride on an elephant is quite nice. Let's go ahead and try number 3. So on your workspace, you would take 34 and you divide it by 5. It's always the top divided by the bottom. Well, counting by 5s could be pretty fast, so I'll just keep track with some tallies off to the side. 5, 10, 15, 20, 25, 30. Oh, 35 would be too much. I better stop. Again, I just got 30 counting by 5s. When I subtract, I'm left with 4. Well, how many times did we say that went in there? I forgot to put a number in the quotient for you. So we'll go back and count up our tallies. We have 5 plus 1 more makes 6. Should I put that in the tens place or the ones place? You're thinking about putting it in the ones place because I was treating that 34 like 34 little ones that I was using up, and 6 times 5 used up 30 of them, so 5 didn't go nicely into the 3 either, did it? I could put a placeholder there, a 0. Can we write this as a final answer? Sure, we would get 6 as our whole number and 4/5 as our fraction. So this is a mixed number, 6 and 4/5. It's always a good idea to check and see if you can simplify as a second step. But in this case, when I notice my numerator is 1 away from my denominator, I'm usually looking at simplest form. I can kind of start to notice a pattern to those. Let's turn the page and look at the next section. Here we're going to be moving from mixed numbers to improper fractions, and this is a really helpful skill when it is time to maybe combine fractions with unlike denominators, if we have to multiply some mixed numbers in this unit. This will come in handy as well. So I'm going to speed ahead here to the quick check where I can give you 3 fast examples. Now my hint for you on this whole section is MAC. This is an acronym that sometimes helps us remember the steps. M tells us to multiply, A tells us to add, and the K tells us to keep the denominator. So if I were to look at the first problem and set it up for you, it's supposed to be a 1. I'll try that again. I have 2 1/2. Well, I worked with a group the other day and they did a really nice job of drawing out what it meant. So it means I have 2 whole bars and 1/2 more. 2 whole bars would be all shaded in, with just one of the 2 pieces here. What if I split all of these in halves? What if I decided to cut those whole bars in half also? I would end up with 1, 2, 3, 4, 5 halves, 1 9. So how do we get that using this MAC idea? Multiply first, so we multiply our whole number times our denominator, and we add our result to the top, to our numerator, and we keep our denominator the same. So let's try it. 2 times 2 gets me 4, and 4 plus 1 gets me 5. 5 over 2, the denominator stays the same. This is the answer that you're looking for line 1, 5 halves. You could also say, hey, that looks like an improper fraction, and it is. The elephant's smushing the chicken again, and if you went about dividing the top by the bottom, it'd take you right back to where we started, the 2 1/2. Let's try the next one, number 2. Here they give us 5 2/3. We could draw out 5 whole bars. We could run out of room. I'm trying to make them about the same size. And notice the bars are being split into 3 parts each. The thirds comes from the denominator. Well, I have 5 whole bars, so shading these in, there's 1, 2, 3, 4, 5 whole bars, and 2/3 more. 1, 2 little parts more. I could count up how many thirds that is. That's like 3, 6, 9, 12, 15, plus 2 more, 16, 17. I'm getting 17 thirds. Is there another way to get there? Let's try macking it. Remember, we multiply from our denominator to our whole number. We're going around in this order each time. And 3 times 5 is 15. When I'm done, I add the 2 extra parts, and I will get 17. And the denominator always comes from the original denominator. It stays the same. We keep it the same. 17 thirds is the final answer. Let's take a look at number 3. Here they give us 6 1/4, and I could definitely draw out 6 whole bars. I could split them all into 4 parts and draw 1 extra bar with 1 little shaded piece out of 4 in it. But we also could just think about that acronym MAC. If you're starting to notice a pattern, this will work every time. 4 times 6 gets me 6, 12, 18, 24. And 24 plus the 1 more up top will get me 25. Now where does that denominator come from? Oh, that's right, it says K. I need to keep it. So it was fourths, it's still fourths. This is the answer they're looking for. Let's move ahead to the next section where it says we're going to multiply some fractions. And I know this is the part that I think my students struggled the most on the other day. So we'll take a quick minute, we'll look at the 3 quick checks at the top and maybe even a problem or 2 below that. So I think that this idea of multiplying fractions and going straight across and multiplying isn't too scary to anyone. So for number 1, I could really multiply 3/5 times 2/3, and I could multiply straight across and see what I get. 3 times 2 is 6, 5 times 3 is 15, and you'd say 6/15. And I'd say, hold up, you actually need to simplify that 6/15. You would look for 6 and 15 in the same row of your multiplication chart, or you'd say, what is their greatest common factor? So maybe you notice that they both divide by 3. I could divide the top and bottom by 3 to get there. This will work. But what we talked about the other day in class was looking for some cross simplification. So when I see numbers that are diagonal from each other, the numerator of the first fraction and the denominator of the next, I can simplify. Maybe there's a common factor that goes into both 3 and 3. Well, 3 is a prime number, so it doesn't divide by much. 1 or 3 itself. And same idea down here, I can divide this 3 by 3 also. Well, when I do that, what do I get? A number divided by itself is always 1. And this number divided by itself will still be 1. I could even look for cross simplifying here with the 2 and the 5, but you can check your chart all day. You will only find 2 and 5 because they're both prime numbers in the 1 row. And that's not super helpful. It won't really change the values. If I divide those numbers by 1, they would actually stay the same. So for that reason, I could do a rewrite step. I could say I have 1 over 5, my new numerator over my old denominator. I'm multiplying, and my previous numerator stays the same, and my new denominator looks like a 1. When I go ahead and multiply across, 1 times 2 is 2, and 5 times 1 is 5. I get an answer of 2/5. And if you go back to our original problem, the way we had first tried it without cross simplifying, 3 goes into 6 2 times, because 3 times 2 is 6. 3 goes into 15 5 times, because 3 times 5 is 15. So either way will work for you. This idea of cross simplifying just cuts down on some really big numbers when the numbers get larger. Let's take a look at number 2. So you have a couple options here. You can multiply straight across. 4 times 3 is 4, 8, 12. 9 times 8 is, 9 times 8, 1 less than 8 is 7, and 7 plus 2 is 9. There's a 9 strip that helped me with that. So I'd get 12 over 72. And this is not a final answer. In fact, you'll probably get it wrong. So what you need to do then is look for it to be simplified. See if you can find 12 and 72 in the same row. And I know that they are in the same row if you use your multiplication chart. I'm thinking that they might divide by 2 because they're both even. They might both divide by 3 because when I add the digits together, they divide by 3. There's something even larger that I'm kind of ignoring on purpose. So you can keep trying that, keep checking your chart. Here's another way to solve the problem. Again, this is number 2, but this is an example of cross simplification. So let's go ahead and look across or diagonally for some common factors. What is something that divides into 9 and 3 nicely? Well, 3 and 9. Oh, they're both in the 3 row of my chart. They both divide by 3. In fact, 3 goes into 3 1 time, and 3 goes into 9 3 times. But we might not be done yet. We could also look across here at the 4 and the 8. 4 and 8, oh, they both divide by 1. They're both in the 2 row because they're both even. They're not in the 3 row. Oh, but they're both in the 4 row. I can divide them both by 4, the greatest common factor. 4 goes into 4 1 time, and 4 goes into 8 twice. And I'm really ready to multiply across. Some people prefer to do a rewrite step here so that they grab the right information. So my new numerator of 1 over my new denominator of 3. My new numerator of 1 over my new denominator of 2. And multiplying across, 1 times 1 gets me 1, and 3 times 2 gets me 6. 1/6 is the final answer. Let's go ahead and take a look at number 3. So again, multiplying straight across and simplifying will always work. It just might make your job kind of difficult because the numbers get kind of big. So what is 4 times 1? 4. What is 7 times 6? Well, you could check your charts. You could count by 7s. 7, 14, 21, 28, 35, 42. I get 42. I notice both those numbers are even, so maybe you can divide them by 2. And remember, whatever I do to the top of my fraction, I must do to the bottom. You might be able to get to an answer that way. But today's emphasis is on cross simplifying, so let's see if we can look at it in another way. Well, I joke with my students, when you see this 1 here, it's as low as you can go. It's kind of like the limbo, so you can't go much lower than 1, right? So in that case, 1 is a special number. It really divides by 1 and itself. It's not quite prime, but if I divide 7 by 1, it won't really change the number value much. So I'm going to look diagonally the other way. I have 4 and 6 to be cross simplified, and they're both even, aren't they? They're both in the 2 row of my chart. Well, 2 goes into 4 twice, and 2 goes into 6 3 times. I'm really ready to multiply across. But because I did some cross simplifying or cross canceling, it might be difficult to see which numbers you have to work with. So let's take a quick minute and clean this up a little bit. My new numerator is 2 over 7. And the second fraction reads 1 over 3. You're ready to multiply across. 2 times 1 gets me 2. 7 times 3 gets me 21. There's the final answer, 2 over 21 for number 3. And that makes sense to me. If I go back and look at the other idea I had, just multiplying straight across and then simplifying would also get me the same result. I hope you had a chance to review a skill that maybe you haven't used in a while in math. These skills are all going to be useful for us in Chapter 3 as we talk about multiplying and dividing fractions and decimals.